good morning everyone. It's really a great pleasure to be today with you all. I've seen already great talks. I don't know if I will be as good as the previous colleagues, but I think it was also maybe by coincidence that the last question, the last topic was about satellite. Since satellite, non-terrestrial networks in the last, say 5-10 years on the one hand with the rise of Starlink and a number of other constellations and the renewed interest of standardization level through 3GPP as is kind of survival experiencing now a kind of a hype again. So it's a big momentum for non-terrestrial networks and satellite overall. And in particular, there are a number of verticals, railway, aeronautics, and others that are more and more interested in its application. Then, of course, there are scenarios where this is kind of straightforward, especially those where connectivity is completely missing or not that effective from a capacity standpoint, and other where instead there is a kind of coexistence, competition with the traditional terrestrial networks in the form of nowadays of 5G and soon 6G and later 7, 8, 9, 10, 100Gs. So this said, let's okay, first of all, I wanted to say a few words about myself, well, not specifically myself, but the institute that I'm representing today, that is DLR, that is Deutsche Zentrum für Luft- und Raumfahrt, so in English maybe it sounds easier, German Aerospace Center, that is the federal, one of the federal research institutes across Germany. We have several sites, several institutes dealing with very different topics. So despite the fact that it's aerospace, we are addressing much more than that. And in particular, I'm with the Institute of Communication and Navigation, KN, that is based in two main sites. So one site is in Oberpfaffenhofen, that is a tiny village west of Munich, where I'm also working. And that is pretty much focused on the communication part and the navigation for a number of sectors. And then there is another site that is north of Berlin, that is in Neustrelitz, that is more around nautical and maritime systems. And as such, there are a number of missions that are addressed by our institute, and in particular, I'm with the Satellite Networks Department, where we are dealing particularly with global connectivity and cybersecurity. The other two missions that are indicated here, global positioning, autonomy and cooperation, are from the other departments of the Institute of Communication and Navigation. Why talk about satellite and NTN, apart from the fact that is my research work, so it's kind of automatic. In our department, we are dealing with a number of activities and projects that are listed here with very different topics, but also perspective, with a number of system and architecture studies, technology developments, and also demonstration. Some are funded by European Commission as part of the SNS joint undertaking. Though not mentioned here, there are also some around the railway as part of the EU Rail joint undertaking, and then of course we have a number of activity either funded by the European Space Agency, ESA, or directly by our ministry here in Germany. As said, very different topics because of satellite, and is also the objective of this talk, is not the kind of old guy that we were used to in the last 20-30 years, just getting a signal from the ground and in a very simple manner, transparently distributing it to the rest of the network on the ground. The satellite has become much more than that. As a matter of fact, this kind of vision was already shared many years ago. Then there was a phase where satellites were kind of going down, and as I said, in the last 10 years the situation has radically changed. Obviously, the the expectation and the hope is that the role of satellite will be more and more crucial in the years to come, in the, let's say, final deployment of 5G and more importantly in 6G. And this is in fact the very next topic, because traditionally satellite at the time 4G, 3G or something like that was kind of another terrestrial access. And at that point in time, I'm talking about 10-15 years ago, joining the force with the terrestrial networks or the backbone networks was never successful and maybe not even tried in the proper way. Then, starting maybe around 2016, 2017, there was the attempt to really show the community what could be the added value that satellite can bring in, and from that point of view on, let's say, from a standardization standpoint, the terms of NTN and non-terrestrial networks was forced. And especially in the framework of 5G, there was the idea of really integrating everything together, integrated design, and then with the perspective of 6G and beyond is really to achieve the unification, so that now kind of motto of NTN is NTN to be a native component of 6G from day one, in order to make sure that really NTN, along with the other network access, is really part of a global picture. This was not the case for 5G because NTN entered into the game once 5G more or less, from a specification standpoint, the concept design and so on, was already there. And as such, the effort done by the NTN satellite community was pretty much to show what can be the added value, and then try to see where a satellite can be put inside, for which functionality, for which scenarios, and so on. With 6G, the approach is pretty much different. And the network vision, because of that, is to have a kind of multi-composite, multi-layer networks that is going to complement, not replace necessarily the terrestrial infrastructure, and as such serving a number of verticals. Multi-composite in the sense that we can have the traditional geostationary satellite, but also the more, let's say, interesting nowadays that are the low Earth orbit satellites, and in between we can also have the MEO, that are the medium orbit. As we may all know, there are many differences in that, especially for what regards, this is the killer of application, that is the latency because of the distance, but there are other aspects that are quite relevant in terms of antenna design, size of the satellites, to take into account what are the limitations that can be imposed in terms of mass, power, computation capabilities, and so on. And as such, we come up with this setup that is one of those developed in the ongoing SNS project. This is coming from the 6G NTN project, where we have, as you can see, kind of mesh networking space that is complementing the counterpart on ground, and you can see from the y-axis to the vertical axis what are the different altitude and distance that we are looking at, and what are the different function and role that we see for satellite to put on board. And why NTN is such, or what is the perspective of NTN? This is somehow confirmed by, on the one hand, what happened recently at the Mobile World Congress, March this year, and also the following up workshop that happened just 2 weeks later in Korea at the 6G workshop, where there was a strong interest, interest of showcasing the NTN capabilities. Then for what regards to the workshop, a lot of contribution, and then also more recently, in terms of the ongoing activities in 3GPP towards the definition of the use case and requirement, this is pretty much the direction in terms of focus. And of course, it's not only NTN, because as also reported this morning from the first presentation, of course, AI is the first one that also plays a role in the general development and support of a satellite system. And because of that, it's possible to identify a number of key performance indicators for a number of general applications: pedestrian, public safety, regular connectivity, airplanes connectivity, stationary video surveillance, and the IoT connectivity. I don't want to spend too much time on this now, because otherwise we need to talk for another hour. Also, but just to give in a nutshell, what is the orientation of 5G, 6G, to see what can really helpful be for the NTN counterpart. And because of that, this is possible to identify a number of use cases that are also pretty much aligned with what is the IMT 2030 vision that we all know has published the documents starting from last year. So for many people, this left-hand side diagram is quite well known, where it's possible to identify what are the usage scenarios, and in particular the ubiquitous connectivity that automatically goes for the use of non-terrestrial networks. Then, of course, it's not just about that, because there is this overarching, that is the outer ring, that is about sustainability, ubiquitous intelligence, security and resilience, and connecting the unconnected. Of course, at the first glance, one could see immediately NTN and satellite as the necessary element for achieving the connection, connecting the unconnected. But we all know that sustainability is a key aspect, and security and resilience is another one. Last but not the least, ubiquitous intelligence, obviously something that must happen also at satellite level. Question mark how to achieve that, but this is objective of many initiatives, many projects, of which I don't want to spend much time today, but certainly is one of the pillars around which NTN and the other components of the forthcoming 6G will have to build upon. And then there are a number of use cases and scenarios that are pretty much aligned with the other, with those included in the other slide, and the corresponding functionalities that are reported on the right-hand side. This is also something that was developed in parallel between the CGNTN project and the 5G Digital last time. Then, to understand a little bit what is the evolution of satellite, maybe we can think what happened in the last 5 years at 3GPP level. So we started with the transparent payload, that is a kind of the classical way satellites have been working in the last 10, 20, and more years. So satellite acting transparently. So just repeating a signal without doing much more than that. Then the evolution, that is what reported in the release 19 that started say 2 years ago, and obviously is continuously progressing with the future release 20, 21 and so on, is to use instead a regenerative payload, so that we can put some intelligence on board, some network function on board. Of course, the fact that we are talking about regenerative payloads is not so dramatically new, because the idea of regenerative payload is quite old as well. But here the idea is really to make satellite nodes, NTN nodes, so space assets generally speaking, smart agent, intelligent agent that are implementing AI functionalities, that may implement a GNOT beam board, a number of advanced network and signal processing capabilities, so that we can really go beyond what has been historically the vision of regenerative satellite. Because if you take whatever book about satellite communications already from the late 90s, you already see transparent, bendpipe if you like, and regenerative satellites. From that point, of course, many evolution at chipset, at ASIC, FPGA, and so on happened, that of course gave an influence on how payload in space should be transformed. But then more recently, in order really to show the impact that satellite could have in space, sorry, not in space obviously, but in 5G and 6G, there was the attempt, the effort in understanding how genome B could be placed either atomically, so as a unique element, if you prefer monolithically in space, or to go for some functional split, as we know, CU, DU, RU, and whatever. And then if we go back to the original picture, it's also important from a networking standpoint. So what are the challenges we have ahead of us? Which solution we can use? Maybe those already available from the terrestrial infrastructure, from the terrestrial network in general, or maybe new ones, or to adapt the existing ones in order to further enhance what's available from space. And there are a number of building blocks. We have just drawn a couple of them. So the coexistence of terrestrial and non-terrestrial networks in order to exploit both links, the multi-link part. There is the general effort in softwareizing networks, so network function virtualization, support for multi-tenancy and such multi-domain orchestration, security obviously a key point, and then transversely there is the big support needed from the AI part. And as such, it's possible to try mapping all these actors into the different capabilities that may offer into this generally unified network architecture. And then eventually we land into a service-oriented architecture where we have a number of actors, verticals that are those presented in the previous slides. We have a constellation, single, multiple, maybe operating in conjunction one with another, and all of this has to somehow play in an harmonized manner, and this must happen by means of AI-driven distributed computing, AI-driven cross-domain network orchestration, in order to have all together the main elements. Of course, this picture is pretty much idealized because hides a lot of complexity that are behind, but this is the general vision that is being put forward by many initiatives, and is also somehow the reference also for the forthcoming standardization in 3GPP as part of the list 21, 22, and follow. And as such, in order to achieve this NT1 ECG from day one, there are all these elements that I mentioned before, that, as you can see, already start kind of moving our traditional view of satellites for just being a data communication element to a data infrastructure, because we are talking about service-centered network, so we are dealing with the services. We are trying to put together or to exploit the edge cloud continuum concept, that is something that is already being used or promoted in terrestrial networks since long, I would say. And why not think of edge computation capability happening in space, not just for mobile networks, but there are different sectors, also in the context maybe of Earth observation and so on, that could be really useful. And then, of course, once again, distributed AI techniques that act on data. So data is the key word that is going to be really reshape the way satellites and NTN overall are going to be used in the next years. Okay, here are a number of technical aspects, and maybe I can go quickly through. There is the multi-connectivity that I was mentioning before, with respect to making taking advantage of different links, terrestrial and non-terrestrial, at the same time. By means, for instance, of ATSS or some other mechanism. There is routing, because we have to transport data from space to ground and the other way around in an intelligent way and in an optimized way. It's not, in this respect, that simple when you have a large constellation and you have to decide the best route, also to make sure that maybe your routing is following some kind of semantics, or that you are able to meet the QoS requirements from the verticals that are sending data one side to the other side of the network. Then, as I said before, there is also the edge computing part, to understand where edge functionality can be placed, to which extent, and so on. And in this, obviously, there are a number of verticals that are supported. For some of the projects I'm also involved, railways, something that can be interesting, agricultural, certainly, also the part of aeronautics is something that has been addressed going this direction. So there are different aspects. And this brings me to the point of thinking of satellite as an edge service, and then talking about satellite as a service. In the past we were mostly talking about IIS, so infrastructure as a service. Why not seeing a satellite playing a very similar role? Of course, there are different assets in space and on ground that must be interconnected from a service perspective in order to achieve such a concept. We cannot forget that no matter how good we are, smart we are, we must provide a proper control framework, and we know that some of this is coming from the ORAN perspective, with the RIC in its non-real and the near real-time part, for which also important work has been done in different NTN initiatives, but in ORAN itself, there is a dedicated working group, so a task force in order to see how to make sure that NTN can really take advantage of the building blocks available from the ORAN architecture. And then because of that, we can think of deployment of the RAN function, VNF placement, and that also, as I go a little bit fast on this, because these are all, as I said before, integral part of this network softwareization plan that started already in the rest of the domain since many years. If you remember the time of when STN started, some 15 years ago more or less, and step by step, also with some resistance from the satellite community, eventually landed also on the satellite part. Of course, doing it over satellite is not so easy on the one hand, because, okay, I can say that typically satellite vendors, satellite operators are a bit conservative, but on the other hand is also the fact that from a physical standpoint, the satellite is an object in space that is subject to a number of constraints in terms of size, mass, power, and obviously we would like to have in space a big amount of power available so that we do big things, crazy things with genome bees, AI, etc., etc. But the reality is that there are important physical constraints, and as such, we have a number of challenges to take into account while designing a system to make sure that we are able to fulfill the service requirement demanded at 5G, 6G level, and so on, in a way, however, that this can be really feasible through a space asset in a distributed manner, in order to be secure and resilient and sustainable at the same time. And last but not the least, why not thinking about 6G NTN for beyond the right-hand side picture is also generated, is also written there by AI. The other one on the left-hand side is kind of more realistic. And the idea, this is something that already emerged in the last 5 years, to put a GNOB tower on the moon surface in order to let astronauts or whoever will be there to talk via 5G. There are activities in this sense already happening at standardization level. Of course, 3GPP, but in particular CCSDS, that is the Consultative Committee for Space Data Systems. And as we know, there are important initiatives at worldwide level about the forthcoming moon exploration, the LunaNet program in US, the Moonlight program in Europe, supported by NASA, plus a number of other initiatives in Japan, China, and so on. And of course, here is also important to understand how the space can really interface with all this terrestrial infrastructure while ported on other planets. Okay, an easier way here on Moon, but there is also to apply this also for Mars and so on. And that's all. So here essentially as I remarked many times, satellite is undergoing an important revision, if you like, in order to be rebranded. Really to be aligned with the needs of industry, society overall, and in general with the trends of 5G, 6G, that is pretty much centered about data. Of course, the data transportation, that is the traditional and original means for data communication, but it's much more than that, because we know nowadays in our everyday life that we are kind of obsessed by data. We cannot live without data, and in this respect also satellite is expected to play its own role. In order to achieve this, however, there are important steps that have to be still fully completed, that we have to see, okay, we put everything on satellite and so on, but what is the cost and what are the benefits of doing that? Because as I said before, there are physical limitations. And then there is the important point that, as I remarked at the very beginning, that at the beginning satellite and terrestrial network were very separated objects. So operators were kind of fighting one with another, terrestrial and non-terrestrial, in order to make use of the available spectrum, etc., etc. So the business models were and are still very different. So if we are really aiming at a unified, harmonized setup, we need a new business model. We need a new way of operating networks, and these are the way really, or the challenges that the community, industry-based, academia, research-based, are facing nowadays and trying to solve all together. And then, last but not the least, not reported here, historically, terrestrial and non-terrestrial networks were kind of seen as kind of forever enemies, so they cannot play or talk each other. I think here, since the beginning of NTN in 3GPP, the view has been different, because on the one hand, terrestrial network vendors operators are now approaching NTN to see how NTN can solve their problem in order to provide connectivity and coverage in a way that maybe they alone will not be able to do it. And the other point is that we are in an era that we have to go towards coexistence rather than competition. Of course, there are specific scenarios where competition will still be there, because of course we cannot say it's only NTN, but there are scenarios where it will still be about competition, but the other is coexistence, and the end is kind of having a win-win situation, so that both sides, operators for both network, can really make benefits, so make profit out of that. In order to that, of course, an important role is played by the industry with the support of a research organization, and we have also to make sure that there is a good work together between the different parties of this feature to make sure that it's not just putting everything together, that's it, but really to develop a vision that is sustainable in the years to come in such a way that what is going to be an ecosystem for 6G is able to evolve in a flexible and effective way towards 7G and 8G, because if on the contrary we are going to build something that is pretty much adopted for 6G, but then 7G has to be redone from scratch, then it's not very effective and market won't like it either. So that's all. Thank you very much for your attention.